We will work with this for a couple of days. I'm going to show you everything today. We'll see how it goes, and then we'll probably practice with it some tomorrow. I don't know. I haven't quite. No, it's not hard. And you basically already know. You know a lot of it anyway. Good. All right, was everybody good on the integral rules? Were y'all okay there? You can split up the integral if you're adding, subtracting, but not if you're multiplying or dividing. You just can't split it up. Yeah, you can't split the integral up if you're multiplying or dividing, only if you're adding or subtracting. Any other questions before I start on this? Okay, come on.
Some look like, okay. I don't remember where the numbers were, and then something like that, right?
Is this just writing it in?
I don't know, like
an integral?
on the AP thingy, it asked us questions of that. Like, I didn't know.
It should have just been writing the integral rule, like saying this is from, it should say like n equals whatever.
Yeah.
Up to some value here.
Yeah.
So if this was 0 to, say, 5, this would be from 0 to 5 here.
But what if it's like x?
You could just put an x there. And we're going to be working with those some like that.
I don't know. It wasn't right. Like, it was like this, and then it didn't do this. I don't know what it did.
I'll go back and pull those and look and see if I can find an explanation.
And then also, how do you know whenever you're supposed to do the antiderivative? Like, do you do that every time?
Every time it's an integral, yes.
So, like, here would I do that? Wait.
Okay, so if it's in an integral form, so if it asked you to evaluate something, like if this went from 0 to whatever, that's, you're finding that's the average value of the function.
Yeah.
Which is different than the average rate of change. Some of you are doing slope.
I just don't know, like, when to do what.
Okay, but it's the AP questions that through.
Yeah.
Okay. I'll print those out and see if I can, and then every day we can go over a few of those, and that might help.
Like, would it tell you when to do average?
And you should be able to, could you not go back now and click on it and see an explanation of them, now that it's been graded? Okay. I'll do a printout of them and see with the explanations and stuff, and then we'll try to divide it up into a few every day, if that'll help y'all. All right. Anything else? All right. Well, then back to fundamental theorem, part 1. Really fundamental. That's why they call it. You remember the fundamental theorem of algebra? What was it? Fundamental theorem of algebra said that it had to do with the zeros of the function. The degree tells you the number of zeros, the number of times it crosses the x-axis. And sometimes it's a bounce, and sometimes it's a repeated solution, but at the end of the day, like if it's a, do y'all remember that or no?
I know that.
You've seen fundamental theorem of calculus? You've technically seen it. No. I think you're thinking average value of function too. So that starts with 1 over b minus a, part 1. Because we hadn't done it. Yeah, this is, 5-4. All right, we'll start with the easy part. If I have an antiderivative that is equal to the integral from a to x And I'm just going to give you the formal definition, and then we'll work a couple examples, and I think you'll see it's not as hard as what it looks like in the definition. If I am differentiable in AB, differentiable.
The integral is like split. Like instead of being a 5 on the top and a 0 on the bottom, it would be a 0 on the top and the bottom.
So you can flip it back and just throw a negative sign in front. So you're saying if it was
Like, yeah, literally like this. It would be a
that, you can do that every
So
time.
you're saying from negative.
You can always flip those bounds and just negate the answer at the end. That always works. Does that answer that question? All right, so I've got this function. What does this capital F mean? Antiderivative. So its antiderivative is equal to the integral from a to x of f of t dt. Notice I've changed some variables up there, right? I'm going from a to x, but I'm saying f of t dt. Y'all okay? Yes, no, maybe so. Okay, so let me show you what it means. Let me show you what it means here. The derivative of f with respect to x. Okay. What? Why didn't I just make x b? I want it to be a variable there because it's differentiable on AB, but what if b was 5 and I wanted this x to be 2? So for anywhere on there, this is true. All right, then that means the derivative, because the derivative of this would equal the derivative of that, right? So the derivative of this is one of those things I told you, it looks super complicated, but when you see how easy it is, you go, oh my gosh, there's got to be a catch, and there's no catch. So the derivative of the antiderivative, which is the same thing as the derivative of the integral, because the antiderivative is the integral, is equal to f of x. So if I've got this variable t, and I take the derivative with respect to x, right, and I go up to x on here, it's just going to leave me with f of x. I told you it's going to look really funky and confusing, but when you actually see it done, I'm not going to go through working this top to bottom for you and showing you why, because I think it would just confuse you, and I think if you just know this, it will help you more. So let me show you what I mean. The derivative of cosine t dt from negative pi to x. What do you think that would be? Do you though? What is f of x? What's f of t? Yes.
Oh, we've done that.
No, you haven't done that. No, you haven't done that. Now, if you went through and you found the antiderivative here, you plugged in the bounds, you subtracted, and then you found the derivative, you would come back to this. But this is what the fundamental theorem is saying, is that you can just look at that and know. It's redundant. Yes. This ddx is saying take the derivative of this with respect to x. Yeah. Yes. Yes. How about this one? I didn't click any fundamental theorem on AP Classroom. The rest of you have seen this too? Or just Dylan? Any ideas what we're going to have to do? It is going to be a chain rule. It is. Have you done this too? Am I losing my mind, y'all? Am I in the twilight zone? Close. You're really close. So my question is, I haven't even put it up here, but find dy dx. In other words, find the derivative. Yeah. Okay. Fundamental theorem is not hard. It's just, okay. This is, yes, I have to do chain rule, but what I'm going to do is I'm going to replace this t here with the x squared, and then I'm going to chain rule the x squared. Okay, so it's going to be cosine of x squared, and then I'm going to multiply it by 2x because that's the derivative of x squared. Remember, we're finding derivatives here. No, if it doesn't make sense to you, you could replace this with another variable, say like a u. We use u substitution a lot. I don't think I'm going to do that. Well, right. If you did it all out and you went step by step and you found the antiderivative here, right, the big f of x, and then you plugged in 1, and then you subtracted 2, and then you found the derivative. You want to do one like that so you can see what happens? Let me do one because it might clear. Okay, what is the antiderivative of, I did it, it is. What's the antiderivative of cosine t dt? Negative sign or positive sign? All right, so I'm finding, let me just write what I'm finding. I'm finding the derivative of the integral of from 1 to x squared cosine t dt. So what we're doing is finding the derivative of the antiderivative, which we said was what? Sine, right? Sine t evaluated from 1 to x squared, yes or no? We're going backwards. So the derivative, the antiderivative of cosine is sine. You follow me? Okay. So I'm still going to have this d dx here. And I'm going to evaluate from 1 to x squared. Which would be what? Sine x squared minus, I will do that in just a minute, minus
We have definitely not done this. We haven't done this. So why do you go minus sign 1? Oh, never mind. That's intervals. All right, so what now?
All right, now we need to do the derivative. Okay, How do we know what that is? Well, watch. What's the derivative of sine x squared? 2x, because that's the chain rule, times cosine x squared. Do you agree? What's the derivative of sine 1? Why is it 0? It's a constant. Derivative of a constant is 0. Does that make more sense? So I should have walked you through to start with. I apologize. The trick is nice. You want me to give you a second to write it down? Or are you good? Oh my gosh. Believe it or not, you are going to have multiple choice questions that literally say, if y equals this, find dy dx. Like, and you will have probably more than one because this is fundamental theorem. So it's, yes. And do it on your own, yes. This is number... Everybody but us. This is number 9. Find dy dx.
Oh, wait, not. You got chain rule twice now?
Yo, you said do it by yourself.
Yes. Okay, so the first thing I'm going to do, since this is just a constant value here and this is a variable value, right? And I'm finding with respect to x. I'm going to plug in my x squared here. So I'm going to have e to the x squared squared, which is...
That's an exponent? Oh my god.
What do you think it was?
That's a normal t. Like, e times t.
Oh, yeah, that was an exponent. I'm sorry. Now I'm going to chain rule. But what am I chain ruling? I'm chain ruling the x squared. So it's going to be times 2x. So it's 2x e to the x to the 4th. Y'all okay? Well, I got a couple more things to show you with this. Not meant, we're it goes through 5. 5, one more section after this. And that's trapezoidal rule. Our test, it'll probably be next week. We don't have a 2 more, not this week. No, because it's already Tuesday. We've got 2 more sections to get through. We got this section and another. No. Y'all are worried about this already, and we don't even know it's going to happen. Okay. Dylan, this one's for you. Find. No, this is my number. Oh, this one's different. Why is this one different?
We have two variables. Yeah, the X is on the bottom. Oh,
So what do we do?
Flip it to make it a negative.
That's exactly right. So what is dy dx?
3x sine x. Negative 3x sine x.
You know it never stays this easy. Yes, this is the same theorem applied, just different ways over and over. You got variables in the top bound and the lower bound. What subtraction thing? Not the average, but keep going with the subtraction thing. Oh, you're talking about, no, we're not even going to have to do that. But this is going back to those integral rules. I am going to have to do something with one of those. What does this fundamental theorem say? What needs to be where? Okay, but the constant we're finding, I need to put dy dx. The constant needs to be the bottom and the variable at the top, right? Do you agree with that? Right now I have from 2x squared. You agree? This is the lower bound, this is the upper bound. How could I rewrite this maybe as two integrals instead of just one? How? I could do 0. That's exactly what I'm going to do. So, do you agree? And actually, let me just rewrite y first. I could go from 0 to 2x. But then I'd have to go from what? Zero to x squared. You're saying like that? You're thinking along the right lines. I am going to have to, but I got to figure these bounds out. Which one's going to be what? So we will, but which one needs to go where? Which one needs to go? What's not going to be negative? I don't know. Yeah, I don't know. Let's erase the bounds. Let me put the function in here for you. All right, 2x 0 where? 2x at the bottom here. So you want 2x here, you want 0 here. This is right. This is right. And here's why. Lowest value it can possibly be here. Yes? So that's in my lowest bound, right? And to it, I'm going to add up to my highest bound, which goes here. But now here's where I have to think about it. This one is an easy eval whenever I do it, right? Because if I find the derivative, that's just plugging in and then chain rule. Then you just make the other one negative. That's exactly right. So this is going to be negative from 0 to 2x, 1 over 2 plus e to the plus 0 to x squared, 1 over 2 plus e to the Say again, I'm sorry. Multiply what by x? You should just be by yes. So this is going to be negative. I'm going to multiply it by the 2 for the chain rule, right? So this is chain over 2 plus e, not ex, right? Do you agree or disagree? Do you see why? Well, it didn't have to, but I just did it at first. It would actually be 1 over 2 plus e to the 2x times, and then the chain rule here would be 2. So I just went ahead and put it on the top. Skip the step. Dylan, we are not killing kittens today. You can't cancel those 2's out like that. Plus 1 over 2 plus e to the x squared, right? But I've got to multiply by, so 2x. Yes. Okay, but point being here, when I'm going from variable to variable, I have to split it up. Make sure your lowest bound comes first in the lower bound, and your highest bound comes last in your high bound. Yeah. There were 2 variables in there. And the only way fundamental theorem works is if that constant is in the bottom. Yay or nay? You talking about swapping the order of them? Yeah, you can. Yeah, you can. Yeah. Right. I'm going to show you second half of fundamental theorem just because you've already done it. And then we'll do the area connection tomorrow. Y'all need a break for just a second? Okay. Theorem part 2. F is continuous. On AB. We're just setting up the definition. It's okay. It's easy. 2. Probably next week sometime. F is an antiderivative of F. This is all your little caveats. Then when you see this, you'll go, oh, but we already know that. And you do. Then the integral from a to b of f of x dx. I think part 1 is the hardest part of the fundamental theorem. Is equal to that very antiderivative evaluated from a to b. Yes. We have already done this. Then this means that we're just giving the formal definition of it now is all we're doing. We evaluate the antiderivative at B and subtract out the antiderivative at A. That is the fundamental theorem. And we've been doing that.
No, not the average.
Yeah. Yeah.
1 over B minus A times.
No, we don't do 1 over
B
B minus
no, for average. F of B minus.
This is the area under the curve, is what this is.
Only antiderivative of B.
We'll be talking about integrals the rest of the semester, like the rest of the, until we finish and then we start reviewing. Huh?
So we do the average thing, whatever the active.
Well, they will literally say, what's the average value of the function on blah?
Okay, so how do you know when to do the subtraction thing or when to, like, it's written down and you just put in an X. Like, if it's like,
So if that's only whenever there's a variable here, whenever you did, like the first part of the fundamental theorem. So that's only whenever this variable differs from a variable that's up here. It's pretty much what that is. You can still, this is the fundamental theorem, and you can use this to get back to part 1 of it. It's just, that was just a little shortcut I showed you. Stop, Dylan, no. No. You can always find an antiderivative and subtract upper bound minus lower bound. Whenever you start getting variables in your bounds, that's when you start thinking about that first part of the.
In order, you can do upper bound minus lower bound.
To evaluate the integral. Yes. This was, because when we have been doing this. Oh, it was?
there was like a 5X in the upper.
All right, let's do a couple because the hard part about this is finding the antiderivatives here. Should we start with a hard one or should we start with an easy one? This is non-calculator. No, it was non-calculator. But this one, I didn't want you to think you could just go. Did y'all figure out what I was saying about the integral on your calculator, how to find it? Yeah. It's the exact same way as the derivative, but just in it. Okay. I need the antiderivative of 1 plus r squared. 1 plus r, whatever. If you did that and you took the derivative, would you come back? So you're saying 1/3. Does that work? Lizzie says that's the antiderivative. Does that work? Why does that work?
Because it's like a 1 and then it'll get squared.
Would not work if it looked this way, right? Then I would be into a chain rule type situation. But because the derivative of r is just 1, yes, it works. You would have to go through and figure out what. You'd have to multiply by the derivative of. We'll get into that when we do substitution. Okay, so I've got my antiderivative, which can be the hardest part of doing this. Now, if you did not understand how to do this, there is another way I could have done it. Look at it. What if I multiplied it out? Boiled it out, r plus 1, r plus 1. Then I'd have a polynomial, and that's easy to find the integral of, right? So I could do it this way, or I could say, well, this is r squared plus 2r plus 1. And then I could do the antiderivative, right? 3 or no, 1/3. It would be taken care of, right? From -1 to 1. Okay, that or no, because I'm a definite integral. Okay, you only worry about C when I'm in an indefinite situation, and we'll talk about that. But because I'm evaluating specific numbers, no, I don't have to worry about the C. If the C were in here, it wouldn't matter because I'm doing top bound minus low bound, and the C's would cancel. So 1/3, 1/3 plus 1² plus 1 minus 1/3 -1³ plus -1² plus -1. 1/3 plus 1 plus 1 minus 1/3, right? Because that's negative. Oh, but it's going to be positive. Right, because this is -1/3. I did the long way here. -1 plus 1. I got 2/3 plus 2, which would be 6/3, 8/3. What y'all got? If you plugged it in from the antiderivative we found in the beginning, you would also come back to 8/3. Either way you want to do it. Don't say bigger minus smaller just because. Say top minus bottom, if you want to remember it an easy way. Because sometimes, remember, they're not big minus, then you got to flip it, yeah. All right, tell me what you think, because that's all I got for you today. It's easy. What? Oh, yeah, you can. You can.